were to find the area of this triangle, and so we draw the picture. That's the first thing you do. Draw the picture, then draw a representative area strip. So representative area strip. So what you do is, you know, you're trying to find the area from x equals 0 all the way to x equals 6. So somewhere in between there, some arbitrary location, you pick an x value, say here, and you draw a, I'm doing a left sum picture. You can do a right sum picture. You can even do a midpoint picture, but I'm just going to do a left endpoint because I get into that habit. It's delta x wide at the x location, and the height of it is f of x. So we're going to have to figure out what f of x is. So we have our 2 points. We have this point up here and this point down here. We get the line joining those 2 points, and when you solve it out for y, you get this. Y equals negative 1/2 x plus 3 is the equation of that straight line. So then you realize the area of the strip is the height times the width. So it's negative 1/2 x plus 3 times delta x. Add an x location. Add an x location here. The height will be negative 1/2 x plus 3, because that's the equation of the line, the y values, times the width, that's delta x. So then we're going to sum all those up, and we use this sort of slang notation. We don't have to get involved in the I counters. We know that the interval from 0 to 6 is going to be broken up into delta x wide subintervals, and the I is going to count something like from 0 to 100 or some kind of step like that. But we don't have to get involved there. We know that that's what's happening. But I do want you to annotate it this way. Have the sum, have the function expression there, delta x, and just say my x's are moving from 0 to 6. And so what you're doing in your mind is you're doing this. You're acting like you see the rectangle here where x equals 0. Then x moves to another value and you're seeing this rectangle, and then x moves seeing this, and you're adding up this area, and then the one that we've shown, and then this one, and then this one, so forth. You move that representative rectangle in your mind left and right, and see if it sweeps out all the area. And treat that as the sum them all up. And then as the number of subintervals goes to infinity, as n goes to infinity, the left Riemann sum will converge to the integral. And here we have that over here. So that's the way you think about these things. Now you turn it into the exact value, 0 to 6, f of x dx. Perform all the algebra of the fundamental theorem of calculus, and you're going to get 9. So 9 units, 9 square units is the area. Now, of course, this is a triangle. So the area of the triangle is going to be 1/2 the base, which is 6, times the height, which is 3, and that does indeed come out to be 9. So that checks out. Another thing you can do to check this, your work on this integral, is to run the program and report the trap n equal 100, and see how close to that you get to 9. So in other words, you can verify your integral every time by running the program. Okay, now another way to do it is this way. run the rectangle areas in the y direction. There's nothing that says that you have to do it in the x direction. So here you would locate a arbitrary y value right here and draw sort of a left quote-unquote rectangle picture, and its height would be x. See, there's some kind of an x value down here. That's the height of it. So you realize you got to take the equation of the line, solve for x, and get this. And then the area of the strip is going to be x times delta x, which is here, which is this. Then sum those rectangles, and in your mind you're going sweeping them that way and that way. Down at the bottom they end up being like this, and at the very top they're like this, and of course they go all the way to a point up there. So sweep that rectangle in your mind upward and downward, and see if it, as you're doing it, if it sweeps out all the area. So then you set up the Riemann sum, y equals 0 to 3 of the height times the width of those. Have n goes to infinity, the number of subintervals. So the area is going to be 0 to 3 of the heights times the widths dy. Factor out to -2. That's just an algebra convenience, because you can do it. So do it if you can. Then work with this fundamental theorem of calculus out, and you get 9. Same answer as before. So that's how you do rectangles moving in the x direction, and how you do rectangles moving in the y direction. Sometimes one way is easier than the other. Sometimes they're equivalent, but you can use either way.